Okay, so we are in the trig functions on the unit circle packet. We've been talking about primarily lately how to evaluate trig functions on the unit circle, and we just kind of reviewed that as well. Now, there was something I talked to you about yesterday to help you figure out where the trig functions were going to be positive or where they were going to be negative. Okay, if you're looking at a grid, you start just like you would name the coordinates, 1, 2, 3, 4, you go counterclockwise, but we say all students take calculus. And I'm just going to go ahead and abbreviate that calc. Okay. Because the first letter of every word is going to tell you exactly what trig function is going to be positive there. The one exception is the A for all, because that does mean all. All 6 of them, from sine all the way through cotangent, are always going to be positive in the first quadrant. What does the S stand for? Sine. Okay, what about the T in take? Tangent. And the C in calc. Okay, there we go. Now, if I were to just go ahead and give you a number, like let's say a positive 5, well, what's the reciprocal of that number? 1/5, right? Now, the reciprocal is still positive. So the reciprocal of these trig functions, they're going to be positive in the same quadrants. The reciprocal of sine is not cosine, cosecant. There we go. Hello. The reciprocal of tangent is cotangent. And then the reciprocal of cosine being secant. Okay, so this tells me exactly where all the trig functions are going to be positive. But more importantly, it also helps me determine where they're going to be negative. All right, so let's look at this type of problem here. And I believe we're about maybe halfway into that packet. It's on the page where at the bottom you have a picture of that robotic arm. Okay. Well, it says let secant of theta equal the square root of 29 over 5. And we're told that sine of theta is greater than 0. Find the exact values of the remaining 5 trig functions of theta. Okay, so let's go ahead and start with what we're given. If anything is greater than 0, well, that means it's what? Positive or negative? Positive. So we're told that sine is positive, right? So what I like to do is go ahead and draw my grid, because ultimately we're going to have to draw a triangle to help me with this. But I'm going to put a check mark in all the quadrants that satisfy my conditions. So what 2 quadrants will sine be positive? Yeah, in the first and the second, right? Okay, so now I've used that. So now I want to go ahead and take a look at secant. Now, secant is actually giving me a number, a numerical value. Is it positive or negative? It's positive as well. Okay, so I'm going to look over here. What 2 quadrants will secant be positive? First and fourth. Now, the reason I go ahead and put these little check marks here is because I'm looking for the quadrant that overlaps. What do you think I mean by that? There you go. So I know that whatever theta is, my terminal side has to be in the first quadrant because that's where I have the most check marks. Okay, that one quadrant satisfies both of those conditions, the values that I'm given. Okay, so I'm going to go ahead and in the first quadrant, I'm going to draw my terminal side. Again, I have no idea how far we rotated. I just know it's less than 90 degrees. Okay. Now, in order to solve the problem, I'm going to use that terminal side. I'm going to connect it perpendicular to my x-axis. Okay. And it's just the same ratio that we've had before. We still have our x, we have our y, and we have our radius, right? Well, what is secant's ratio? Oh, not y over r. Okay, it's r over x. There we go. Secant is the reciprocal of cosine, so its ratio is r over x. Well, compare that to what you're given. We know that secant of theta is equal to the square root of 29 over 5, but I know the ratio is r over x. So this is telling me exactly what a couple of my sides are. I know that the radius is the square root of 29. And I know that the x value is going to be 5. Okay. Does everybody see how I did that? Well, now, how am I going to figure out that remaining side y? Yeah, the Pythagorean theorem. Okay. So let's go ahead and do this. A squared plus b squared equals c squared. So we always want to set it equal to the hypotenuse squared. So I'm going to say 5 squared plus y squared is equal to the square root of 29 squared. Okay. And that's just going to be 29. That's right, because the square and the square root cancel. So 25 plus y squared is equal to 29. Okay. Now what do? Okay, minus the 25. Okay, so y squared is equal to 4, and he's absolutely right. Now I need the square root. So y should be 2. Okay. Now this problem is just like what we've been doing earlier in the week. We've got the triangle with all 3 sides. I just want to find all the remaining trig functions. Okay. Like for example, let's say I want sine of theta. Okay, remember sine of theta, that's always y over r. Well, what was the y value we just found? 2 over, we know that the radius is the square root of 29. And then we always want to rationalize if possible. But does everybody see how I created the ratio? Okay. So square root of 29, square root of 29. So it looks like I'm getting 2 square root of 29 over 29. Okay. And then I just want to do the same thing for the rest. Let's move on to cosine. Cosine of theta. What was his ratio? X over r. Okay. Now, maybe some people out there have already noticed we've been dealing with the unit circle, right? But is this problem the unit circle? How do we know? There you go. The radius isn't 1. See, imagine, the circle would go all the way around like this. Here, the radius of the circle is the square root of 29. But even though we're not on the unit circle, I mean, isn't all the trig ratios still the same? That changes nothing. Okay. All right. Get rid of that circle. So let's see. X was what? Okay, 5 over the radius we know is the square root of 29. And again, I would want to rationalize that. So it looks like I'm getting 5 square root of 29 over 29. Would you guys agree? Okay. Okay. And then we would just, move on. Tangent of theta. And we actually just did this. What was tangent's ratio? It's always y over x. Well, let's see. The y value was 2 over the x value of 5. Don't have to do anything special there. Okay. Now I want cosecant of theta. What's cosecant of theta? R over y. So r divided by y. So this time the radius is the square root of 29 over the y value 2. Okay. Now, could I have also just taken the answer for sine, flipped it, and rationalized? Yeah, but why have to go through all that work if the diagram gives you what you need? See, I don't have to rationalize that. Okay. Do we need secant? No, remember, the problem started by giving me secant, so we don't have to worry about that. The only one left is cotangent of theta. Remember, his ratio was x over y, so it would end up being 5/2. There you go. Okay. How we feel about that? Okay. Let's try another one of those. Right below it, we have cosecant of theta is equal to -3. Tangent of theta is less than 0. Okay. So if it helps, go ahead, draw your grid. We know that all 6 are going to be positive here. What was positive in quadrant 2? Sine and cosine. I'm sorry. Cosecant. All right. Then in quadrant 3, tangent and cotangent. And in quadrant 4, here's the cosine and the secant. Those are the quadrants where these will be positive. All right, well, let's start with tangent. It says less than 0. So what's it telling me about tangent? It's negative. Okay, well, if I know that tangent is going to be positive in first and third, that means he's negative in the second and the fourth. So I'm going to go ahead and put a check mark in each of those. Okay. So I've used him. I don't have to worry about him again. Now, is cosecant negative or positive? He's negative. So where am I going to see a negative cosecant? Okay, 2 and 3? We're close. We're halfway there. Because think about it, cosecant is going to be positive in 1 and 2, right? So cosecant would be negative in 3 and 4. So where's the overlap now? So it has to be in quadrant 4. That's where this triangle has to be. Okay. So I know here's my terminal side. Now, just like the previous problem, this is going to represent my radius. Okay. I'm going to connect it to the x-axis perpendicular. Here's my right triangle. And again, we have no idea what theta is, but it's always my reference angle. Remember, the reference angle is created by the terminal side and the closest x-axis. Okay, well, what did I do on the previous problem to find those side lengths? Yeah, just look at the value that I'm given. So, like cosecant, we're given that's negative 3. But remember, that ratio is r over y. Now, this one isn't a fraction, so how does that help me? There you go. If it's not a fraction, put it over that. Now, don't worry about the negative. We'll go ahead and talk about the negative in just a second. So I know that the radius is 3. The y value has to be 1, right? So I'm going to say 3. I'm going to put the 1 right here. We don't know what the x is. Now, one of these has to be negative. Which one would it be? The 3 or the 1? Okay. Has to be the 1. The thing about the radius, it will never be negative. The radius is always positive. And also think about, if you're plotting a point, if I wanted to go from the origin to this point right here, I'd go right, but then what tells me to go down? The fact that it's a negative 1. Okay. So there we go. All right. Now, there is one other thing we got to do, and what is it? Pythagorean theorem, because we don't know what x is. Okay. So let's see, x squared plus a negative 1 squared is equal to 3 squared. So x squared plus 1 is equal to 9. Now what? Okay, subtract the 1. So x squared is equal to 8. Now here's the thing, on the previous one, we ended up with a perfect square, everything was great. If you do get a number that's not a perfect square, okay, we don't want to go decimal, okay, we want to go ahead and leave it as is, but we want to simplify it if we can. Now what does that mean, simplify? Yeah, look for the largest perfect square that'll evenly divide it. So the square root of 8 equals, well, what's a perfect square that'll evenly divide 8? 4, because the square root of 4 is 2, right? And see, that's the idea. I can't take the square root of 2 without getting a decimal, but I can take the square root of 4. So this would be 2 square root of 2. And think about, what quadrant are we in? Are we in quadrant 4? So would that 2 square root of 2 be positive or negative? He'd have to be positive, because going to the right, you'd be positive, correct? Okay. Is everybody okay with what I've done? Okay. And then now we would just go ahead and do exactly what we've done in other classes, what we just did a few moments ago. I'd go ahead and figure out all those other trig functions, like, for example, sine of theta. Remember, sine is always y divided by r. Well, what's the y value? Negative 1 over 3. And that makes sense because sine and cosecant are reciprocals, right? And it was telling me that cosecant was negative 3, so I should be getting a negative 1/3. Okay. All right. How are we doing on time? All right, so I'll tell you what I'm going to go ahead and do. I'm going to kind of forego the rest of this problem because I'm pretty confident that everybody could just go ahead and get those ratios now. Once you have the triangle, that's the biggest part. Okay. Let's take a look at this problem here. Now, one thing about these types of problems, you are going to be dealing with special right triangles, but just like we talked yesterday, it may not be on the unit circle. So let me show you what I'm referring to. Let me get rid of these real quick. Maybe. Delete. Delete. Okay, so let me get a couple of triangles here. Okay, so let's say I've got a couple of right triangles, and I know that I'm dealing with either a 45, 45, 90, or I'm dealing with a 30, 60, 90. Okay. Now, if we know for sure we're on the unit circle, okay, if the radius is 1 because we're on the unit circle, we already know these lengths. We know this has to be square root of 2 over 2, square root of 2 over 2, because they're congruent. If it's on the unit circle and it's 30, 60, 90, what's always across from 30? 1 over 2. Now, what's always across from 60? Square root of 3 over 2. So these triangles you're going to be very familiar with because of the unit circle. But what if we're not on the unit circle like this problem we're about to look at? Okay. We would just need to know the relationship. Let me go ahead and erase all these. And I think we did one of these the other day. Okay. All of these can be written in terms of x. So for a 45, 45, 90, the legs are always x units long. The hypotenuse would be x square root of 2. Isn't that right, Rhett? Yep. Okay. Now, in a 30, 60, 90, across from 30, the shortest side is always x. Well, how does the hypotenuse compare to the x side? It's always double it. So the hypotenuse is always double the shorter side. And how does the longer side, the longer leg, compare to the shorter leg? It's always x square root of 3. So if you were to go ahead and say, like, if x is 1/2, you'll see where we get those other values from. So what's 2 times 1/2? See, that would give you the 1, and then 1/2 times square root of 3 is square root of 3 over 2. So see, it still has the same relationship. But if we're on the unit circle, we really don't kind of have to bother with that. Okay. Well, let's look at this robotic arm. Okay. A student programmed a 10-inch long robotic arm to pick up an object at point C, looks like a tennis ball or a baseball, whatever that is, and rotate through an angle of 150 degrees in order to release it into a container at point D. Find the position of the object at point D relative to the pivot point O. Okay, so what this is saying is, let's imagine that this pivot point right here, that's the origin. That's where the x and the y axes cross, right? So this ball right here, what coordinates would he be at? Oh, not 0, 0. 0, 0 is right here.
0.
Okay. Now, you're right, except what's the length of the arm? It's 10. So this would be located at 10, 0. So this is an example. See, we're still dealing with a circle, but this one won't be the unit circle. Okay. So what's going to happen is this arm is going to rotate 150 degrees, and I want to know the XY coordinates of where it ends up. That's what we're looking for. Okay. Well, you'll notice this is, again, why reference angles are going to be so important to us. Let's say that the arm, that's the hypotenuse. You see we've got the x-axis? We'll just connect it as we have been. What would the reference angle be for 150? It's 30 degrees. Remember, the reference angle is always created using the terminal side and the closest x-axis. So let me go ahead and recreate this over here where I have a little more room. This is the origin 0, 0. Okay. Then I have this right here. This is where the ball is going to end up. Okay, so we said this was 30. Remember, this is where we rotated 150 degrees. So if this one's 30, this one's got to be what? 60. Now, if we are certain we're on the unit circle, well, then my side lengths are just 1, 1/2, and the square root of 3 over 2. Those same values that we've been looking at on the unit circle. But what's this radius here? 10. And just remember the relationship. Across from 30, you always have x. The hypotenuse is always 2x, and this one is always x square root of 3. Yeah. So if that hypotenuse is always double the shorter leg, well, then the shorter leg has to be what? It's got to be 5 inches. So what would the longer leg be? Yeah, all you got to do, once you have x, you just plug it in. 5 square root of 3. Now, this is where it's very important. You got to think about what quadrant you're in. See, here's the origin. So what quadrant would this ball end up in? Quadrant 2. So what am I missing here? What would tell me to go from the origin to this point? Negative. We'd have to go left of the origin. If I didn't put the negative, then it would tell me to go right. So what are the coordinates of the ball after we finish up? Well, from the origin, you had to go -5 square root of 3 inches left. And then how high did you go? 5 inches up. And again, we're not saying that that's a -5 square root of 3 inches. We're just saying that the negative is telling me what direction to go. And what? Oh, because we were told this was the origin. So imagine, you've got the XY axis, the system going right through it. Okay. All right. Okay, good. Now, let's see here. We don't have that much time, but why don't we go ahead and take a few of these, and at least we can get a few in. We'll get those in for another grade. Okay. Does everybody have a copy of the assignment? This one right here with all the circles on it? I think I should have some extras over here. Maybe. Yes, we do. Okay, here it is. Who needs a copy? There we go. Okay, who else? Okay, who else? Anybody? Okay. So we'll just, work a couple of problems here. Now, I did go ahead and put one like numbers 2 and 8 on the test tomorrow. Do you want to go ahead and start with one of those? Okay. Now it says the given point lies on the terminal side of the angle theta in standard position. Find the values of the 6 trig functions. So what do you like, number 2 or 8? 8? Okay. So it's -1, -2. Let me give myself some room here. Okay. All right, so for number 8, we have the point -1, -2. All right, so if I were to plot this point, what quadrant would it be in? Okay, the 4th? 3rd, right? Because from the origin, you'd have to go left and then down 2. So let's say it's right about here. Well, what the problem is saying is that you're going to start in standard position, and you're just going to rotate, and when your terminal side stops, that point is going to be on it. That's all it's saying. So this would definitely put me in the 3rd quadrant because of the point, right? Well, just like we've seen several times, I'm going to use that terminal side to go ahead and create a right triangle. And there's theta. Okay. Now remember, the coordinates of this are -1, -2. So do I happen to know this guy right here? Yeah, it's -1. And again, we're not saying that's -1 units long. The negative just tells me the direction. So what would the height of the triangle be? -2. Okay. So how would I find that radius? Yeah, Pythagorean theorem. So let's say the radius r. So -1 squared plus -2 squared is equal to r squared. So it looks like 1 plus 4 is equal to r squared. So what's the radius? Okay, so the square root of 5 is equal to the radius. Now that you have the triangle, it just wants you to find those 6 ratios, just like we've been doing. Okay, so let's start with sine of theta. Is everybody okay with how I created the triangle? Okay. So let's see here. Sine was always y over r. Well, what was the y value we had? -2. Remember, that's my vertical. So -2 over, we found the radius to be the square root of 5. Is there anything I got to do to this guy? Got to rationalize it. So square root of 5, square root of 5. So what's my answer? There we go. Okay. Now we want cosine of theta. Well, what's cosine? It's x over r. And is this a problem on the unit circle? No, because the radius is not 1, right? But is it changing anything? It's not changing a thing. Okay. So let's see. My x value this time is a -1 over the square root of 5. So what would be my final answer? Nathan's absolutely right. Negative square root of 5 over 5. Okay. And then, of course, we would just keep going for those other 4. Okay. How are we doing? Okay. Hello. Now, I'll tell you what, I did say we were going to go ahead and turn that in for a participation grade. Did you guys want to hang on to that paper until tomorrow to go ahead and get a little extra practice? I'll go ahead and tell you one of the biggest items that I put on your test was going to be problems like these, where you just find that particular angle measure and then using the coordinate do what the trig function does. Like, for example, cosine of 4 pi over 3, right? Okay, so let me find a unit circle real fast. Okay. I want the cosine of 4 pi over 3. Well, first off, where's 4 pi over 3? Oh, not second.
The third.
See, it's in the third. So here's 4 pi over 3. There's the ordered pair that goes with it, right? Well, what does cosine want? He just wants the x. So that would be -1/2. That's it. So then tangent, oh, not x over y, y over x. So I would take that y value and divide by the x value. Okay. So I'll tell you what, just bring this back tomorrow. We'll go ahead and turn that in. Like I said, I'll give you that participation grade. Okay, perfect, perfect. Thank you so much, guys. Great.